Hello, my little mathematicians. Today we're going to review mods 11 and 12. Now, since this is a study guide, you should already know how to do all this. So go ahead and try all the ones that you can. Okay, so pause the video, try all the ones that you can, and then once you've done them, then you'd unpause the video and come back with us and check yourself. All right. Or you can check yourself on the answer key and then fast forward the video of the part that you need help on. Okay, so you tried them all yourself, and now you're back with us. For the first one, point A is right here. Remember that when you're graphing points, okay, the first number is always your x. The second number is always your y. The first number tells you right or left. The second number tells you up or down. What do you think if it was a positive x and a negative y? What would you do? Well, x is right or left, so think like a number line. If it's positive, do you think that's right or to the left? Yeah, it's to the right. That's where positive numbers are. And then the second number tells you up or down, so where does it make more sense that negative numbers would be? Up or down? Down or negative numbers. So if it was positive x, negative y, it would be right and down. What if it was positive x, positive y? Where do you think it would go? Right or left? Right for positive. And up or down? Up for positive. What if it was negative x and then negative y? Well, that would be left and then down. And finally, what if it was negative x, positive y? Well, negative means left, and the positive, up or down, it is positive. Okay, now the numbers actually tell you like how many right or how many left and how many up and how many down to go. So for A, that's right here. First number tells you right or left. It went left, so that's negative. And how many left did it go? Between the 6 and 8 is 7. And then it went up, so that's positive. How many up did it go? 2. B is right here. It went to the right, so positive how many? Positive 1. And then down, how many? Just 1, so down 1. Also, when you're counting, one little trick is it's not 1, 2, 3. You don't actually physically count until you move. So 1 is when you actually move. 1 doesn't start here, that's 0. You don't hit 1 until you actually move away from it. And so some people like to draw little loops to help them count. Like maybe they went 1, 2, 3, 4, 5, 6, 7 over to the left and 1, 2 up. Okay, if you need to draw the little loops to help you, that's fine. All right, my next one says point C is right there, and it went all the way 8 to the right, and then up how many right there at the 6. Okay, D is right here. It went left all the way over to negative 7, and down how many? It went in between 8 and 10, which is negative 9. Okay, point E is over nothing, but down in between 6 and 8 is 7. And then this one, F, went to the right 4 and up nothing. So there we go. We labeled all the coordinate points. Then they also ask you which quadrant or axis is it on. So A, you're like, I know it's there, but what quadrant is that? Draw a big giant C for coordinate plane, and then follow your C. So it goes 1, 2, 3, 4. Or again, 1, 2, 3, and 4. Because remember, they labeled the quadrants with Roman numerals. Okay, so A, as you can see, is in quadrant 2. B is right there in quadrant 4. C right here is in quadrant 1. D is in quadrant 3. And then E, you're like, it's not in quadrant 3 and it's not in quadrant 4. It's on this line. Well, what line is that? That's the y-axis. And what quadrant is 4, 0 or point F on? Right here, it's not in 1 or 4, it's on this line of the x-axis. Okay, so if they ask you to label the coordinate point, there you go, -7, 2, 8, 6, 0, -7. If they say what quadrant is it in, then you either label the axis or the quadrant and do them with Roman numerals. They could also ask you, please plot the point -2, 9. So -2, is that right or left? Hopefully you said left 2. Then what? Up 9 or down 9? Well, it's positive, so hopefully you said up. Okay, so left 2, up 9 would put you right there. And so you label the point there, and then your G, you can put there, 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 or there, right? Okay. Now you have the point H at 8, 0. So I'm going to go right 8, up nothing. So all the way over to 8 and up nothing would be right there. And I'm going to label it H. Again, as long as you have the point there, you can put the H just somewhere around it. Any of those places would be fine. Okay. Now you've mastered graphing on the coordinate plane. Let's focus if they give you a word problem, identifying independent, dependent variable, filling out a table, and all the parts of graphing. Okay. The word problem says Jack saves $2 a week. That sounds like the rate to me. Remember that the rate usually divides it up as Y per X. So it's the money per week. X is always the independent and Y is always the dependent because your answer depends upon what you did to X. 2 is the rate that you're going to multiply the X by. So again, Y is the money. So if he saves $2 a week, what are we talking about for the money? It's not $2 because that's the rate. And independent and dependent variables don't change, or they can change. It's not a fixed number. And he saves $2 every week. So $2 is the rate. I want to name something that can change. So what did you say? Hopefully you said something like the money that he saves, like the total money saved is your Y. And that depends upon, well, how many weeks has he been saving? Because after 1 week, he'll have $2. After 2 weeks, he'll have $4. 3 weeks, he'll have $6, and so on. And if you're like, what did you just say? Well, okay. When you complete your table, let's say at the starting point, after 1 week, 2 weeks, and 3 weeks, I'm going to use my equation of Y equals 3x, right? Because my rate, sorry, not 3x, but 2x, because my rate was 2. So I'm going to multiply that with my independent variable because that's how much you make. It's $2 times however many weeks you've been saving equals the total money you have saved. So I'm going to substitute in some numbers for X in order to get my Y. And whatever I substitute in for X, I'm going to plug into my equation of 2 times X. So 2 times 0, 2 times 1, 2 times 2, 2 times 3. My equation is Y equals 2X. And so I'm going to pick some values for X, substitute them in to get my Y. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. And that's where these numbers come from. So if they asked me to complete a table, I'd say 0, 0, 1, 2, 2, 4, 3, 6. Because when X is 0, at 0 weeks, he hasn't saved anything. After 1 week, he saved $2. After 2 weeks, he saved 4. And after 3 weeks, he saved $6. I hope you're seeing the pattern. Okay, now we said that the independent variable is always the X, and the dependent variable is always the Y. So if it tells you to label the X and Y axis, you're not just labeling X and Y. That's already done. You're saying, what is it talking about? Well, the Y is talking about the money saved. So let's label that as the money saved. Okay, or the total money saved. The X axis was talking about the number of weeks. Okay, so I labeled the X axis, I labeled the Y axis. Now I want to graph 4 points. So I'm going to graph these points that I picked. So 0, 0, right there. Over 1, up 2. Over 1, up 2. Over 2, up 4. And over 3, up 6. Now you graphed those points, so go ahead and connect them with a straight line. When you go to connect your points, if one of them is off of the line, you know you did something wrong, because all of our equations should make linear equations, which means they make a perfectly straight line. And if something isn't on that line, recheck your points. You did something wrong. Okay. That's everything from that problem. So now let's move on to down here where it says write and graph an inequality for the given situation. Max wants to make more than $15 an hour. So X and 15 is what I'm comparing, right? I want this to be more than 15. So I'd put 15 in the middle, one number bigger, one number smaller. Is it an open or closed circle? Well, it's not including the 15. He wants to make more than that. So I'm going to leave it open. And then where are numbers more than that? To the right or to the left? To the right. And notice that this inequality sign right here, the greater than sign, matches my arrowhead. So whenever you put the variable on the left, your inequality will match your arrowhead. All right, let's try this one. Everything in the store was 99 cents and less. So we're talking about X and 99 cents. Okay, it was that and less. So it's including that, but also less than that. Okay, so at 99 cents, which is really close to like $1 and then 0, right? So it's including the 99 cents. So I'd put it right there as a closed circle. And then is it bigger or smaller? Well, they said at this store, nothing is allowed to be more than 99 cents. It's that or less. So it goes to the left. And notice that your inequality matches your arrowhead. Okay. You need to be at least 74 centimeters to get on the ride. So you have something that you're comparing to 74. So at 74, you have bigger and smaller. Okay, at least 74 inches. So can you be equal to that? Yes. Can you be greater than that or less than that? At least that. So you can be 74, but we prefer you to be taller. If you're less than that, you can't go on the ride. So that means that it's going to the right. So this should be a greater than sign, and it's underlined because it's including that point. And some of you are like, well, wait a minute, least, isn't that a less than sign? Whenever you see the word at or no, it's the opposite way you think. Because think of it, you have to be at least 16 years old to drive. Can you be less than 16? Can you have little 2-year-olds driving a car? No. Okay, so you should be older than that, or you can be equal to it. So whenever you see the word at or no, it's always including that point, and it's the opposite way you think. It's not a less than, it's a greater than. And if it was at most, it would be a less than, because again, the opposite way you think. Okay, just a little helpful hint, but you can always use your graph and test it of which way makes more sense to also help you create your inequality. Ariel spent less than 2 hours on her phone. So we're talking about this in 2 hours. So one bigger would be 3, one less would be 1. She spent less than 2. So she didn't spend equal to it. And did she spend more or less? She spent less going this way. So it's a less than sign. Again, your inequality matches your arrowhead. If it's open, it's not underlined. Not underlined, open. If it's closed, it's underlined. Closed is underlined. Now, this for us, all of these are correct. However, in future grades, we might need to think a little bit harder on problems 14 and 16, because here it says everything in the store was 99 cents and less. So yes, it is closed going to the left, and there's our inequality just like we did. But technically, can things be less than 0 mean like in the negatives, which means the store would be giving you money for taking the thing out of the store. I mean, I wish they'd pay me to take their items, but no, they wouldn't do that. So it would be like a line segment stopping there. But that's coming for later. Just something to think about. But right now we're just getting the direction of left or right down for 6th grade. Okay. But eventually, like there might be line segments where it stops and it's just from here to here, and things like that. Same with this one. Technically, this is the graph, but you can't spend negative amounts of time on the phone, right? So it would stop probably at 0. It would only go from 2 all the way to 0, and then it would stop. It wouldn't keep going all the way to negative numbers and stuff. These two, straightforward, because, you can be as tall as you want. And then here, you can keep going. You want to make more than 15? Sure, they can pay you $100 per hour if you want, keep going. Sky's the limit, right? But for these, you can't have negative values, so it would stop. But that's a Math 7 issue. Okay, I just wanted you, as long as you have these, you get them right. Let's move on. Solve the following equations. Now, speaking of, next year we're going to be dealing with positives and negatives, like -2 and -7 being combined, and it'll get really confusing. So I know that you can do so many of these problems in your head, but we're practicing the inverse step for when it gets harder. Okay, that's mainly what we're grading you on for this quiz. So draw a line down from your equal sign. How do you get y by itself? I need to get rid of this -9. The inverse of -9 is to add 9. Whatever you do to one side, you do to the other. The reason I did that is because 9 minus 9 cancels. Now you have y by itself. And then simplify. That's 11, 1, you get 21. So you would put y equals 21 in the answer column. But first, double check. Get used to checking so that next year when they're tough, you know how to check to see if you got the answer right. So I wrote the original equation, and then I just substituted in for y what I think y is, and then simplify. 21 minus 9. 11 minus 9 is 2. Bring down the 1, so that's 12. Bring down your equals. Bring down your 12. That's a true statement. So then I'm like, yes, 21 was the right answer. Let's move on. Okay, so show the inverse step on both sides, and then plug your answer that you got back in to check. And in the answer column, you'd write y equals 21, not 12. Y equals 21. That's the answer. This was checking to make sure that 21 was the right answer. Okay. Here, you want to get x by itself. So how do you do it? What's the inverse of adding 4? To subtract 4. Whatever you do to one side, do to the other. I did that because 4 minus 4 is 0. Now x is by itself because x plus 0 is x. 6 minus 4 is 2. There we go. I solved for x. Let's check to make sure that I'm right. X plus 4 equals 6. Plug in a 2. That's what you think the answer is, and simplify. 2 plus 4 is 6. Bring down your equals. Bring down that 6. 6 equals 6 is a true statement. So then you're like, yay, x equals 2 is the right answer. Okay. For this one, 12 is being multiplied with the e. What's the inverse of multiplying? Dividing by 12. Whatever you do to one side, do to the other. I did that because 12 divided by 12 is 1. So you have 1 times e. It's just e. You got e by itself. 84 divided by 12 is 7. Let's go ahead and check that. 12e equals 84. You think e is 7. Let's see if that checks out. 12 times 7 is 84. Bring down your equals. Bring down that 84. True statement, so yes, 7 was the right answer. When you have a division problem that's written horizontally, do me a favor and rewrite it vertically. Okay, so x divided by 7, this is still saying x divided by 7, but I did it this way because now you can see the inverse of dividing by 7 is to multiply by 7. Whatever you do to one side, do to the other. Now those cross-canceled and became 1. So 1 times x is x. I just showed it vertically because now you can see like when you multiply why they cancel, because these cross cancel out and become 1. 1 times x is just x. And then whatever you do to one side, do to the other. So 7 times 7 is 49. Double check. Well, x divided by 7 equals 7. 49 is what we think x is. 49 divided by 7 is 7. Bring down the equals. Bring down the 7. True statement. So yes, 49 was the right answer, and that's what you put in the answer column. Okay, now we want to identify the independent and dependent variables and write an equation for the given situations. So 21 says McBurger earns $2 for every cheeseburger sold. Whenever you see the word per, each, or every, that's usually your rate that you're going to use that gets multiplied with your x. So y equals 2 times x. And then your every kind of separates y per x. So y is not the $2. That's your rate. You're multiplying that times the x. X is talking about the number of cheeseburgers sold. Y is talking about the total money. Okay. Again, x and y change depending upon the problem. 2 is a fixed rate, so that gets multiplied by your x. X is always your independent, y is always your dependent. That never changes. Just what it's talking about within the problem changes. So here, x is talking about the number of cheeseburgers sold. Y is talking about the money, right? Y per x, so the money McBurger earns. It's not the $2 again. $2 is a set rate. That's what's get multiplied by the x, the number of cheeseburgers sold, to tell me the y, the total money earned. Okay, so there's my equation. Then it's asking me if McBurger sold 100 cheeseburgers. So y equals 2x. If he sold 100 cheeseburgers, then how much money did they earn? Well, the number of cheeseburgers is talking about x. So I'm going to plug in $100 for x. 2 times 100 is 200. So how much did they make? $200. This one, okay, it's the same problem, so same equation, y equals 2x. What if McBurger earned $60? Then how many cheeseburgers did they sell? Well, this time they gave me the y, because y is talking about the money earned, right? So I'm going to replace y with 60 and solve for x this time. So to solve for x, 2 times what is 60? We'll divide by 2. 2 divided by 2 is 1, so you have 1x equals 60 divided by 2 is 30. So they would have sold 30 cheeseburgers in order to make $60. Sometimes they give you the x, sometimes they give you the y. That's why it's important to know what x is talking about and what y is talking about within your equation. Okay, number 22. Again, if you missed it, hopefully this helped. Maybe you need to rewatch that part, then maybe retry the other ones and then unpause it and come back to check. Okay, Carly donates half or 50% of every dollar she earns. This one's a little bit trickier, huh? Okay, so what's X and what's Y? Well, your money that you donate depends upon how much you earned. Because whatever you earn, you take 50% of that to donate. So I'm going to say Y equals 50% or 1/2 of X, where X is the money I earn, take half of that, multiply it by 0.5, and then that's going to tell me how much money to donate. Okay. So, and again, this is saying the same thing as that. Y equals 0.5x is the same thing as 1/2 x. So if that's my equation, y equals 1/2 x. If they told me she earns 10,000, how much did she donate? Well, the money earned is x. So 1/2 of 10,000. Half of 10,000 is 5,000. So she's going to donate $5,000 because she made 10,000 and she made a commitment that she's always going to donate half of whatever she makes. The next one says, if she donated $100, then how much money did she earn? Okay, so y equals 1/2 x. And this time they told me the amount donated. The amount donated is your y. So I'm going to replace y with 100. Okay. Well, right here, these are being multiplied, right? 1/2 times x. When you multiply with a fraction, that's like multiplying by the reciprocal of 2/1. And if you're like, wait, what? Because when you divide with a fraction, 1/2, normally you would say, oh, divide it by 1/2. Divide, because we divide, just like over here, we divided by that number. So this time I'd divide by 1/2. Well, when you have a fraction, you keep the first one the same, change division to multiplication, and flip that second fraction. So you can just kind of jump a step of when you're dealing with fractions, you multiply by its reciprocal, because division changes to multiplication, and you flip that second fraction in order to get it to cancel out, because these cross cancel. 2 and 2 become 1, and you have 1x, right? Whatever you do to one side, you do to the other. I multiplied this side by 2/1, or 2. So I'm going to multiply this side by 2. 2 times 100 is 200. So she would have had to make $200 in order to donate 100. And if it's something tricky like that, instead of just accepting it, like, think about it. Okay, so she always donates half of what she earns. So this should be double that amount. Okay, yeah, 200 is double that amount. It makes sense. Okay. All right, for this one, Lucy goes to the fair. It costs $8 for admission and an additional $4 for each ride. Use C to represent how much money Lucy spent and R to represent the number of rides she went on. Okay, so first of all, you have this 4 for each ride and 8 for admission. Remember when we said we saw the word per, each, or every? That usually gets multiplied with your x, right? But then we have this 8 here. Well, that 8 is a one-time fee. So you pay $8 just to get in, then plus $4 depending upon how many rides you go on. And normally that would be the equation. But this time they said, hey, use these variables instead. We want C to represent how much money. So the money depends upon how many rides you go on. So it'd be 4 times the number of rides plus 8 equals the total cost of the fare. Okay, so they want the equation to be C equals 4R plus 8. But if they didn't tell you to use C and R, I would say Y equals 4X plus 8. And now let's go ahead and substitute it in. So C equals 4R plus 8. Lucy goes to the fair and goes on 12 rides. Then how much did she spend? Well, what do you think? Do I plug the 12 in for R or C? Hopefully you saw that it's talking about the number of rides, so I'm going to plug it in right here for the R. And then that will tell me the total cost. So 4 times 12 is 48. Then you're going to add 8 to that. Well, 48 plus 8 is 56. So it would cost $56 to go to the fair and ride 12 rides. Okay, what about this next one? It says Lyndon pays $20 for his cell phone service plus $4.50 for every gigabyte of data. Yeah, you want unlimited that he uses every month. Use C to represent the cost of the service and G to represent the number of gigabytes used. So first of all, let's do it in Y and then we can replace it, right? Okay, we have this $20 for her cell phone service and then $4.50 for every gigabyte used. This is my rate. So I'm going to multiply the X with the 450 or 4.5 plus an additional $20 just for like using the cell phone service. Now they say, okay, use C to represent the cost and G to represent the number of gigabytes. So instead of Y equals 4.5X plus 20, they want C equals 4.5G plus 20. But you can see that it's saying the same thing. They just specified for your independent and dependent variable to use C and G. All right. So here's my equation. Now they asked me, okay, if Lyndon used 3 gigabytes of data in December, how much did he have to pay? So the gigabytes is what they told me, so I'm going to plug that in right here. And that will tell me the total cost. So 4.5 times 3, that's 15 plus 1. 12 plus 1 is 13, and I need 1 decimal. So 13.5, but it's talking about money, so let's put 0.50 plus 20. So $13.50 plus an additional $20. When you're adding, line up those decimals. So I don't put the 20 over here. $20 gets added to the $13, and then you add the cents. So really make sure that you line up your decimals. Okay, so 50 cents and 3 and 3. So my total bill would be $33.50. All right. Hopefully you did pretty well on those. If not, feel free to rewatch the video. Try some of the extra study guides for additional practice if you need to. Congratulations, my little mathematicians. You have now mastered graphing and identifying independent and dependent variables, as well as coming up with equations and solving.